Well, but only ko may sukan na marami na ito niya.
Good evening, everyone.
Good evening, madam.
Okay, so welcome for today's session. For today's session, so warm welcome to all for today's session, which is presented by Mrs. Sangavira Vijayaraghavan, who is working as a senior automation test lead in Cognizant, Chennai. So it is my great pleasure to welcome Mrs. Sangavi Vijayaraghavan, a renowned expert in the field software testing, to the faculty development program today. I am very proud to say that she is the alumni of our institution. She was completed her UG in Dhanlakshmi Srinivasan Engineering College in Perambalur and her MBA in Madras University, Chennai. She was worked as a quality analyst in EH Tech Solution Private Limited, Chennai in 2017 to 19, and 2 years worked as a senior automation test engineer in Medivar Digital Private Limited, Pondicherry. And also says more than 8 years experience in software development and full stack testing. Now says currently handling 25 members of team, and also says creating an automation test plan and getting approval, and also says worked for Tasca integration with Jenkins, SOAP UI, AWS, and having experience in functionality testing, training automation, and Postman. Now currently working in IVR testing and handling Zero automation tool. And also she completed various certifications such as Selenium with Java, Cucumber, JMeter test, and Tosca, AWS. And she received Best Social Worker Award from Deputy CM, and Best Social Activist Award from XPM. So, we are grateful to invite Sangavi Vijayaraghavan to share her time and expertise with us. We look, we look forward to a stimulating and informative session, and we are confident that her presentations will be a valuable additions to our FDP. So, once again, I am warm welcoming Sangavi Vijayaraghavan for this FDP. And once again, welcome you all. Welcome you, Sangavi ma'am. Yeah,
Thank you, ma'am. I will wait for 5 more minutes and the session will be started by Mrs. Sangavi Vijayaraghavan. Thank you.
Yeah, hello everyone. Thank you so much. So it's a very pleasure for me here with you all today. So first of all, I just want to extend my heartfelt gratitude to Dhanlakshmi Srinivas Engineering College and my staffs and faculty, and a special thanks to all my amazing staffs, faculty members. So especially Gopi sir, Geeta ma'am, Gokul sir, Raja sir, really just it was very immense pleasure that I need to show my gratitude here. So without you all, right, this is not impossible in my career that I have shaped myself and for my career development and everything. So for that, I feel very gratitude and feel very thankful to you all and to our management. And so today just it's a very crucial role in shaping my career and personal development as well. So this is the first platform helps me to get guidance and support towards my entire journey. And still I'm in a learning phase, not stopped my learning, still I'm pursuing my MSW. So the first phase of our life is very important. So this Dhanlakshmi Srinivasan makes me more impact in my life and helps me to gain more knowledge. So so it's very such a vibrant and intelligent group of institutions and staffs and members. I feel very thankful. And when I was a student, much like all of you only, and I was remembering all my similar challenges on my dreams. So where to pursue, where to achieve, so what to achieve, so what is everything, how we are going to be in the future. So all kind of situations that I've handled it, and when I was a student, then I overcome everything. And there's some particular moments I just want to explain here. Some of the particular moment, the perspective, right, that the staff has given some more concern about us, our students' career, everything. So they have given more chances to take seminars, and they have stimulated us to take most seminars. So that is why helps me to develop my confidence level. So here I'm standing with you all to share my knowledge, what I have working so far. Yeah. So today I just want to talk about quantum computing. So that is very incredibly important for our future and growth. Okay. So you can wonder that quantum computing can do anything in this world, right? So let me go ahead and share my screen and start my presentation. Yeah, please let me know if your my screen is visible.
Yes, madam, visible, ma'am.
Yeah, thank you so much. Actually, so so in the future technology, right? This quantum supremacy is the one of the fastest technology. So hope everyone must hear about this quantum computing, on quantum physics, quantum supremacy, everything, right? So this quantum supremacy is going to change our entire world actually. So this quantum supremacy is when quantum computer can perform a task that a classical computer can do it. In all kind of factors, like even in a prime factors, classical computers can take years and years of years and years of time to complete a prime factorization
Oi.
concept. But if you're taking this quantum supremacy, right, it will take
Hmm.
only a minute, 2 minutes, or 3 minutes to complete that factorization. So this kind of, not only in prime factors mathematical, it is quantum computing is working. Okay, it is working under traffic management. So recently, right, this Volkswagen, so they have introduced some new concept by using the quantum computing. So they founded, with the help of the quantum computing, right, they have routed 418 cars to the airport without any slowdowns. So in route, you might be knowing that in roadways, right, in India, that we cannot able to travel faster comparing to abroad countries because our roadways are not that much good actually. Even though they have just successfully completed this task, this Volkswagen taken this as a challenge, and with the help of the quantum computing, they have routed 418 cars through the roadways by reaching the airport without any slowdowns, and they have achieved it. So in for traffic management also it helps us, and also not only for traffic management, in all the industries, like this is weather forecasting. Nowadays weather forecasting is very much tough. Recently we were faced multiple issues in forecasting the weathers, because the weatherman is forecasting something, but happening, this what is happening around us is something different, right? This climatic changes is happening many times, and we cannot able to predict it accurately. But with the help of the quantum computing, I'm assuring you that we can 100% sure we can predict the weathers. And coming under to the drug development also, right, to finding the new drugs and to finding the new vaccines. Say for an example, recently this AstraZeneca has founded AstraZeneca and Oxford University combinedly, they have founded this Covishield vaccine. Okay, this quantum computing plays a major roles in finding the Covishield vaccine. So finding the vaccine and finding the introducing the new drugs and implementing the new drugs to the publics. So it is a very very useful thing that in the real time examples. And also coming under to the battery optimization, right? So in the battery optimizations also, it is helping us to renovate the battery and automate the battery. So automate the battery conditions level. It can able to check whether the battery condition is good or not, whether we need to be rechargeable battery or not rechargeable battery. So everything can be done using this quantum computing. And Sepor finally with flight path simulation. This is a very very just interesting topic that I have learned recently. I've just gone through this blogs also regarding this flight simulations. Flight path simulation is very very tough thing. Okay, because they need to properly land, take off the flight to the proper place. So it is very easy to land in the airport, because in the airport is everything is a predefined, and no need to check for anything. Okay, just they need to check whether that place is available or not in that airport, so they can take off the flight very easily. But identifying the path in the airways is not that much easier thing. So for that, right, this quantum computing plays a major role in that, and identifying the best path for the plans to take off in the proper place and everything. So it will not make any error during finding the best path, right? It will not make any error. If the any error still now no errors has happened actually. So if you ask me questions like any quantum computing will not do any errors, right? Yeah, absolutely. The quantum computing will do errors, and it also have many kinds of disadvantages, drawbacks, everything. But it has more features comparing to all kind of future upgrading technologies, right? So it can be tied up with all kind of future upgrading technologies. It can be combined with AI, because without AI, nothing is running in this world, right? So just in IT fields, everything is AI. Just Copilot, Gemini. So they have founded multiple chatbots, chat GPTs, everything, right? So it helps us to improve our career also, not only in career field, for learning, just those who are in learning phases, and also for students and college going students, school going students. This copilot is making an amazing job. So for everything, this quantum computing is the backend to support for all the features. So these are the just basic thing about quantum supremacy and quantum computing. So I just want to make the session needs to be interactive. So if you have any doubts in what I've explained, or if you have any other things needs to be added on, please let me know. I'll just give 2 seconds. Hello. So no questions. Actually, while I'm studying in college, right, I used to ask more questions. My professors will be getting irritated. I will ask more questions. Even if I'm not aware of the concept, also I'll keep. I just want to talk about something, so I'll be asking more. I'll be more interactive in classes. I'll keep on asking more questions, and only we can able to learn single thing from that session. So I'm expecting some questions or any replies, or I'll go to the next session. Okay. Okay, I'll move on to the session then. Yeah, this as I've explained you the brief, just a high brief on quantum computing, right? This is the technical brief about the quantum computing. So the technical brief about how it works, how technically it works, what is the science behind that, and how can be engaged with the quantum computing, and how what are the uses of the quantum computing. So how it works technically. So we are going to study about that. This quantum computing is the principle of mechanics. So quantum mechanics, superposition, entanglements. This is the three major area this quantum computing principles. So based on the three principles only, this quantum computing leverages will work. Okay. Without these three mechanics, this quantum computing will not be possible. Okay. So there is can anyone please tell me what is meant by classical computers? Classical computers. What is meant by classical computers?
Operated with zeros and ones.
Madam, a classical computer uses either 0 or 1, but
Yeah,
in quantum
actually,
both.
yeah, your answer is partially right. But the classical computers, the way we are feeding is zeros and ones. Okay, what are the data we are feeding to the classical computers, right? So that is zeros and ones. But classical computers is nothing but the in day life we are using all kind of tablets, mobile phones, our laptop, official laptops, personal laptops, and our college systems. Everything is a classical computers. So this classical computers, so how we are feeding the data to the classical computers, that is the bits. Okay, in classical computers we'll be feeding the data with the concept of bits. Okay, with the help of bits is nothing but zeros and ones. Only the computers can accept zeros and ones. So all the whatever the data we are giving to the computers, right, everything will be converted into bits, and the bits will be able to perform in the computers, and then only we'll be able to see all those inputs in the screen. So the classical computers and quantum computers. The classical computers is nothing but in day life what we are using, like tablets, mobile phones, systems, everything. Okay, and also quantum computing. Quantum computer is nothing but it is just little bit just next level of computer. Okay, so the thing which cannot be implemented in the classical computers, that can be done using the quantum computers. So that is the difference between classical computers and quantum computers. Say for an example, right? If the classical computers, I'll just ask you some questions, okay? So consider this multiplication, okay? So we can easily do some factorizations like so multiplication like 2 into 3. 2 into 3 means we can easily find the answer 6, right? And if it is a two-digit number, we can use some calculators. If it is a three-digit number, we can use some calculators to do the two number multiplication. So for that, we can use classical computers, even calculators, our mobile calculators, everything we can use and find the answers for that. So consider the situation like this, okay? The situations, wait a minute. Consider the situation like this. So if you want to find the answer, so you want to find how we can get that question of that answer. I'll open the notepad. So consider this 2, 3, 4 and 4, 5, 6. So this answer can be easily found out using calculators, and also with the help of all kind of just manual calculation also we can able to do. But with the 1, 2, 3, 4, 5, 6, we want to get the question for this. So which two numbers if we get multiplied, so this answer needs to become. We need to find this answer. This is called factorization, right? So if you want to find the factorization question for this, so we need to find what is the answer. So for that, we need in classical computers that the factorization is not possible. It will take more time to calculate the answer for this. But if you are using a quantum computer, right, it will take only just 2 or 3 minutes to calculate the answer for this. You can understand. You can come with me. Hello.
Yes, madam.
Yeah. The same way, right? This is a difference between classical and quantum computer. And also in classical computers, there will be bits. And quantum computer, we used to call it as qubits. That is the difference, the major difference. In classical computer, we'll be calling it as bits. Bits will be either, classical bits will be either 0 or 1. In quantum bits, we'll be calling it as qubits. Qubits also zeros and ones. And also it including all probabilities of zeros and ones, not only zeros and one, all probabilities of zeros and one. So and also it can be exist in multiple states. It can be exist in multiple states. This can be I'll be if one qubits, right, one qubits is equal to two bits. So if in qubits it is 0, in two bits it will be, in classical bits it will be 2 0. In qubits it will be 1. In classical bits it will be 2 1. And also I said you right, this all probabilities of zeros and one in qubits. That is called superposition. So this is the term we used to call. Superposition is nothing but all probabilities of zeros and one. Either it will be 0, either it will be 1. Either it will be 1, either it will be 0. It can be anything at the same time. Parallelly, it can be anything. Say for an example, consider a hummingbird. Okay, so hummingbird, if the hummingbird feather is down means consider that is off. Off means 0.
Ma-
The hummingbird feather is up means it is 1. It is
ma-
on.
Madam,
Just yeah, please tell me.
I interrupt you. I'm sorry for interrupting.
Yeah,
There
please
is
tell me.
there is a noise and there is a music or some we can hear it. It's disturbing. Please. Okay, thank you.
Okay. Yeah, just give me a moment. Yeah, give me a minute. Okay, is it fine now?
Yeah, madam. Yes, madam.
Yeah, okay, fine. Yeah, just I'll go with the example, real-time example. Okay, consider the hummingbird. Hummingbird feather, if it is down means, so consider that as 0. Hummingbird feather is up means consider that as 1. Okay, if the hummingbird is flying on the sky, will you able to find whether it is 0, that hummingbird is up or down? Will you able to just figure that out? So that is impossible, right? It will, you cannot able to predict what it is 0 or 1, because in the same time, right, it will just keep on flying and going on the sky. You cannot able to predict it is on or off, whether it's up or down at the same time, at the same parallel time, right, it will work. it will work. So that is called superposition. It can be either 0 or it can be 1. It can be 1 or 0. So to calculate this kind of things only, we have a quantum algorithms. We have multiples of algorithms to calculate this superpositions. I'll just go ahead and explain the remaining sessions. Okay. Before that, I'll just play this video. So before playing the video, right, I'll be explaining the key principles which I said you. I have clearly explained this what is mean by superposition. Superposition is nothing but the qubits can be in a state of 0, 1 or both simultaneous 1 or 0, 1, 0 or all probabilities of zeros and 1. So that is called superposition.
Hello.
Okay.
Hello.
Yeah.
Ma'am, I
Yes.
have a doubt.
Yeah, please tell me.
This is the case. That is, you will not be knowing whether it is 0 or 1. How do
Yeah.
you implement any kind of cryptographic keys to that?
Yeah, I'll come to that. I'll come to that. That is a third principle that we need to apply. Okay, I'll explain you that. Just yeah, that is a good question. So consider this is a lock. Okay, just you guys needs to answer for this. So consider this is a lock and key. So the key to open the lock is 1 and 0. But if this we are assigning this task to the classical computers, so classical computers needs to find the answer for the key, this lock. This lock answer is 1 0. Okay, if you are assigning this task to the classical computers, right? So first what it will try 0 0, because simultaneously it cannot able to apply two zeros and ones. Only it can apply either 0 or 1 in classical computers. So classical computers first try with zeros and 0. It for that it will take 1 second, and second time what will do is like 1 1, it will try for 1 1 other possibility, so that also wrong, so it will take another second. So third possibility is like zeros and ones, so that is also wrong, so third seconds also wasted. And finally it will found the answer. Takes 4 seconds in a classical computers. This is a simple example. Okay, just try to getting understand. I will give you more technical examples in the upcoming slides. Okay, consider this is a quantum computer. Okay, if the quantum computer can able to do all the probabilities in the similar line itself, it can able to do, like it can try 0 0 1 1 0 1 1 0. So now someone asks me questions like whether how to find the answer for that, right? Because if it tries all the possibilities, how to find the correct answer? Someone asked now, right? So for that I'm answering now. To find the correct answer only, here this interference is playing a major role. This quantum interference is playing a major role to find the correct answers of the appearance of the respective questions. So this interferences helps to manipulate all the probabilities of the states, and also helps us to finding the correct answers of the quantum questions. Because the superposition will be keep on doing all the probabilities at the same time. So finding the answers for that only that is interference plays a major role. Ma'am, someone asked a question, right? So did you got my answer? Hello.
Yes,
Yeah,
ma'am.
someone. Yeah, you asked me. You got it right. This interferences plays a major role before the cryptography plays a role, right? This with the help of the interferences, quantum will manipulate all the probabilities and it will find the correct answers. You got it?
Yes, Ambika ma'am.
Hello.
Yes, sir.
Yes,
You
fine,
can,
madam. Thank you, madam.
you can,
Yeah. Okay.
so
Thank you.
I just have one more doubt.
Yeah. Please
Actually,
tell me.
before transmitting, also we can have some encryption keys. After the
Your voice is not audible. Can you please come again?
before, if at all I am supposed to transmit the data. Now, for
Okay.
instance, let me tell it is some IoT device. I'm trying to
Okay.
transmit the data. I
Okay.
can put some cryptographic keys.
Yeah. Yeah. Yeah.
Ma'am,
Please go
Ambika
ahead.
ma'am. Ambika ma'am.
Yes, sir.
Yes, ma'am. Ma'am, kindly share your query to chat box, ma'am. We will get back to you. Okay.
Yes, sir. Yes, sir. Thank you, sir.
Yes, ma'am. Thank you. Thank you, ma'am. Sangavi ma'am, you can continue.
Yeah, okay, Sashas. Thank you. Yeah, I'll just play some videos now for your reference, okay? And I'll come to this entanglement, okay? Entanglement after playing the video.
Ma'am, still background noise is coming, ma'am.
Yeah, let me play this video and I'll just go ahead and check that. Sorry for that.
Sangavi, few noises coming from your side only. I think so. You can check it that there will be a
Yeah,
little bit
let
noises
me
coming.
check, sir. Yeah, let me check,
Okay.
sir. Just
Okay. Okay.
let me share my video and let me check and come back.
Okay.
Is my video screen visible?
Yes.
Yes, madam.
When you
Yes.
suddenly hear your stomach begin to grumble, you decide to head to a fast food drive-thru and you order a hot dog and a hamburger. They are put in similar boxes and handed to you through the window. You have no way of knowing which box has the hot dog and which has the burger. Obviously, once you open one of the boxes and see a burger, you will immediately know that the other one has the hot dog. This means that the hot dog and the burger are entangled in a certain way. This is roughly the idea upon which quantum entanglement is based. Look around you. Everything you see, perceive, and interact with in the real world follows the rules of classical mechanics. This is a study of the motion of bodies in accordance with the general principles first laid down by Sir Isaac Newton. But what about objects that are really, really small? Do they also follow these same laws of classical mechanics? Believe it or not, the answer is no. When things get that small, quantum mechanics takes over, and things start to get extremely weird. Quantum mechanics is the language of tiny particles like photons, the particles that make up light, and the particles inside an atom, such as protons, neutrons, and electrons. To give you a rough idea as to the size of these particles, consider this. The tip of a needle is so large that it could fit billions of electrons. Small electrons truly are. Now that you have a general idea of the size of electrons, let's talk about identities. If someone were to ask, "Who are you?" what would you say? Probably your name, right? Now, let's assume that an anthropomorphic raccoon from another planet asks you the same question. What would you say then? Perhaps, "I am Peter Quill, a human from Earth." In this case, you specified 3 levels of identification. Similarly, in a 3D space, X, Y, and Z coordinates are used to specify an object's exact location, as no 2 objects can have the same X, Y, and Z coordinates. If you consider a 4-dimensional space with time, t, as an additional dimension, then no 2 particles can have the same 4 coordinates.
What if I told you that the root cause of procrastination is not fear of failure, but fear of success?
In the same way, an electron has 4 levels of identification, consisting of 4 quantum numbers. Every electron within If you like this video, then please leave your comments below and subscribe to our channel for more animated stories on the science in our experiment devised by Austrian-Irish physicists as a superposition of both up and down spin. Only when measured do they give a definite value of up or down, which, in technical terms, is referred to as the collapse of the wave function. In quantum mechanics, wave function collapse occurs when a wave function, which was initially in a superposition of a few states, reduces to a single state due to interaction with the external world. When a pair of electrons are generated, interact, or share spatial proximity, their spin states can get entangled, which is what scientists call the quantum entanglement of electrons. Once the electrons are entangled, the 2 electrons can only have opposite spins. That is, if one is measured to have upspin, the second immediately becomes downspin. Now, we know that the two electrons, unmeasured, do not have a single spin, but a superposition of both up and down spin. If we were to separate the two electrons arbitrarily far, say we put one in a physics lab on Earth and another in a different lab somewhere in the Andromeda galaxy, and we measure the spin of the electron on Earth, we will immediately know the measurement of the one in the Andromeda galaxy. For example, if we measure the Earth electron to have upspin, we immediately know that the other electron has downspin. This information traveled instantaneously, faster than the speed of light. As one can imagine, this idea greatly bothered famous physicist Albert Einstein. It was such a disturbing realization, in fact, that he called this phenomenon spooky action at a distance. So how can this spooky action at a distance be useful to us? Well, let's start with one of the most common everyday objects, the clock. Having a common synchronized clock is very important in today's world. They keep things in line, like stock markets and GPS systems. Today, we have extremely precise clocks, known as atomic clocks. The quantum logic clock at the U.S. National Institute of Standards and Technology, NIST, in Colorado will neither lose nor gain 1 second in some 33 billion years. Entangled atomic systems would not be preoccupied with local differences and would instead solely measure the passage of time, effectively bringing them together as a single pendulum. That means adding 100 times more atoms into an entangled clock would make it 100 times more precise. Entangled clocks could even be linked to form a worldwide network that would measure time independent of location, vastly expanding the technology of GPS systems and telecommunication. Then, of course, there's quantum cryptography. As a kid, did you ever make up a secret code language that only you and your best friend could understand? Imagine that, but with the key to cracking the code being randomly polarized photons entangled with each other. That is quantum cryptography. Today, some tech companies use QKD, quantum key distribution, to design ultra-secure networks. In 2007, Switzerland tried out an ID Quantique product to provide a tamper-proof voting system during an election. This system promises to be highly secure because if the photons are entangled, any changes to their quantum states made by intruders would be immediately apparent to anyone monitoring the system. Researchers at Japan's Hokkaido University developed the world's first entanglement-enhanced microscope using a technique known as differential interference contrast microscopy. Using entangled photons greatly increases the amount of information the microscope can gather, as measuring one entangled photon gives information about its partner. How about quantum teleportation? Is it possible? Yes, teleportation is possible in the world of subatomic particles, but it's entirely different from the way teleportation is depicted in movies and popular culture. Quantum teleportation involves the transportation of information rather than the transportation of matter, which is the specific type of teleportation typically focused on in science fiction. Physicists continue to delve into and understand more about the capabilities of quantum entanglement. Once we are able to fully harness this knowledge, it could potentially revolutionize every aspect of our existence. Until then, we will continue to try and make sense of the principles of quantum mechanics because, let's face it, it's a strange branch of science that doesn't seem to make any sense in the real world. Basically, as Nobel laureate Richard Feynman once said, if you think you understand quantum mechanics, you don't understand quantum mechanics.
Yeah, so everyone just gone through this video, right? So they have clearly explained what is meant by entanglement and quantum interference and everything. So entanglement is nothing but what they have explained. Clearly they have explained, right? If the electrons, something the electron is going upwards means so one electron will go towards down. If one electron is going right side and another electron will be going left side, so this is called an entanglement. So one object will, if the one object is getting entangled with another object, so the distance is not matter. So if that object is in India and the same object is in another object is in US means, so the distance is not a matter. If it is an entangled means, so that opposite reactions will happen to the same object. So say for an example, this the coin as shown in the video, right? The coin, if the coin is head here, so absolutely the coin another coin in the US will be a tail only. And also the consider this two boxes they have showed in that video, right? The one boxes contain cat means and another boxes is going to be absolutely burger. So another boxes is going to be burger means, so on this boxes is going to be cat only. So this is called entangled. So this is the main concept in this quantum computing. With the help of the entanglement only, so all kinds of algorithm is going to work. Okay, so this Einstein and many kind of scores algorithm. So this algorithm is mainly based on this entanglement only. If you are clear with this entanglement only, you can able to understand the principles and concepts of this quantum computer. Okay, and also this mechanisms highly based on all to helps us to solve all the complex problems. So if you want to do all kind of bits calculations and factorization calculations, so everything is entanglement is going to help in the future. I'm just going to next screen. So as I said, right, this quantum computing was introduced in 1980, and this is called Richard Feynman. So then only he has founded the term was quantum supremacy. So that was coined by John Preskill. Okay, so this is on John Preskill to get advantages of all the classical systems. Okay, and they have crossed various milestones to achieved and success in this field. They have faced many technical issues, and from 1980 to 2012, right? Still, this research of quantum computing in progress state only. Okay, not fully completed. Still, many of the companies and industries is, invested in quantum computing, and they keep on trying with the same quantum computing to upgrade the skill. So I already have explained you clearly that what is meant by supremacy. So it is the outperforms of the classical computers to being on work on specified tasks. Okay, so it helps us to perform all the calculations quickly and able to do all the domain finding quickly. Everything it is very useful. The supremacy. And coming under to the supremacy, right? This already I've explained this in previous slide itself. It was coined by John Preskill only, and because of the superposition and only this quantum computing can be able to find whether this is a classical or quantum computing equations and everything in the normal day-to-day life. Okay, so this term will be defined as a QS, and quantum computing will be defined as a QC. In technical field, right, this terms is very important because they'll be mentioning like QS, QZ. So you need to know about what is meant by QZ and QS. Okay, and as I said, you explained you what is the usage of quantum supremacy in the previous slides, and now I'm again explaining you for solving all the complex problems and finding the multiple solutions for the single problem, and finding just how to improve the efficiency of the respective applications or industries, how to develop the industries. Everything it is very useful, and also finding the new drugs and everything. Okay. And the key experiments recently, right? The Google has done the key experiments and achievements. Just a minute. Yeah, sorry for the inconvenience. Actually, if the slide is not visible, means you need to tell me, right? Okay, no issues. Yeah, this quantum supremacy, I've explained you this, right? So whatever I've explained in oral communication, right, that was mentioned in this presentation. If you want, I can share this presentation to you for your future reference. These are the usage which I have explained you, and this key experiments. This coming under to the key experiments and achievements, right? Recently, recently they are in uh, researching phase only. Okay, recently this all kind of companies like Google's, IBM, even in Cognizant also they are doing some researches in Google with the help of the Google Cloud and AWS. Right, they are doing researches using the quantum computing. Okay, and also, சொல்லுங்க மேம்.
என்டையர் ஸ்கிரீன் பிரஸ் பண்ணல, ஸ்லைட்ல இந்த இதுல பவர் பாயிண்ட்ல தான் காட்டுது.
Yeah, so the Google, right, that it helps to demonstrate all the quantum processors. Seriously, the Google did a very just impressive thing on using this quantum computer. So all the all the industries and all the domains, right, they were in researching phase only. But this Google has absolutely done this experiment and successfully founded the solution also. Okay, the thing is like they have found one sycamore processor. The sycamore processor, right, this completed the task in 20 seconds, which this classical computer takes 10,000 years to perform the same computation and permutation. So the same computation and permutation, this computer take 10,000 years. The normal computers take 10,000 years literally to complete the task, but this faster computer, this quantum computer, take only 200 seconds to complete the same task. So with the help of the sycamore processor, there is 51 qubits they have used. Okay, with the help of the 51 qubits, they have completed, enrolled, designed this sycamore processor, and this is really this random quantum circuit on the sycamore processor. So for this also, the video is there. I'll play this video at last. Okay, and. This implications of the quantum supremacy, just you can ask like how far it is reaching to the industries, and how far this potential transferring and technologies is just in only into IT field or into all kind of fields, you can ask. But I can assure you this is quantum computing is being in various fields. Okay, it is transforming into different kinds of shapes and different kinds of implications in multiple industries, not only this IT industries. All kind of industries is absolutely trying to utilize this quantum supremacy in a very efficient way. Okay, say for an example, technology, science, industries, everything. So I'll just explain you some of the key implications where it is working and how it is discovering the cryptography, everything. Okay, this as previously I'm explaining you again and again, right, to complex solving all the complex problems. You might think what are the complex, so everything can be manually everything cannot be manually just derived, right? So what are the some of the problems that needs to be done with the help of calculators or with the help of computers, or we can do some programming concepts to solve that problems. So like this, right, this quantum computers can solve multiple n number of complex problems. How? You just know, just imagine like 2 power any number of values can be easily calculated with the help of quantum computers in a seconds, not in a minutes also. In a seconds it can be completed and found the solutions for that. But the classical computers cannot able to do those n number of problems. Even in the drug discovery and material science, nanotechnology, and all this nanotechnology is very nowadays the just emerging technologies in this world, right? So in that also finding all those drugs so recently they for HIV, they're trying to find the drug for HIV, and for cancer recently, the 2 days back, they have just announced that they found some drugs for cancer patients. So this everything for all these kinds of activities, this quantum computer plays a major role. Okay, and also this advancement in cryptography. Cryptography, you might ask what is meant by cryptography. Okay, this cryptography helps us to avoid any just many kinds of insecurities happening in this just online world. Okay, to avoid all those insecurity and everything, so this in cryptography plays a major role with the help of the algorithms and such important protocols, right? So they are securing the communication. What are the communication that I'm speaking with my manager, that needs to be very secured? So what are the communications that I'm doing with my client or anyone else, that need not to be shared with any of the persons, or it should not go with other team members or anyone else. Okay, so for that the security plays a major role. So because this nowadays in the healthcare industries, right, without the secured application, if you're releasing any application to the development to the staging to the production, right, it will create a major problem, because the security is more important. Not only in healthcare domain, in all the domain, the health security is more important. So for that, this cryptography plays a major role. Okay, and also in artificial intelligence and machine learning, right? So this plays a major role to solve all this machine learning algorithms and finding the chat GPT question and answers, okay, and optimizing all those problems. So to enhance more thing nowadays, chat GPT can do anything. Chat GPT can answer anything. This copilot can answer to answer anything, right? So this quantum supremacy plays a major role in helping technically to this artificial intelligence and machine learning and everything, okay, and also finding all kinds of pattern recognitions, okay, because AI cannot able to do any kind of robotic things. So upcoming days, this is also going to be in automation. We cannot able to do this pattern recognition, just the pin code recognition, this kind of things we can, it cannot be automated. And also in development also they will be hide those part, okay, but this pattern recognition can be enhanced more using this quantum supremacy. So as I said, you right, this industrial applications of quantum computing supremacy. So these are the applications, how it works, the cryptography, and what are the implications, and how it reduces the probability of data breaches, because the data breaches should not happen. still still there is some issues, okay, still there is some issues in the data breaches. The 35% of the issues only they have reduced, okay. Still that researchers in progress, they are finding multiple solutions and to make it as 100 percentage. In drug discovery also they have improved 4 times better, okay. In previously it was failed with rat, it was failed with multiple animals and etc. Then only they have moved their researches to the humans. When it is moved to the humans, they directly, without any samples, right, they directly used in us this, that is a Covishield. Because at that time, during the COVID time, right, there is no enough time to do the research process and anything. They need to save the people, to save the people without doing any proper researches and inserting on animals anything, right. This process has been like only after discovery, directly it was injected to human only, not before injecting to any animals. It was directly injected to humans as a vaccine process, okay. And also in financial modeling also it plays a major role. In financial places or many financial losses like share markets and everything, right. Everywhere that losses can happen, because every the share market plays a major important role nowadays. Everyone started investing on share markets, even the school children, as we can see in googles and everything. The news has been broadcasting over the social medias. Even the school students, college students, they started investing on share markets. In share markets, multiple n numbers of sites were there to learn about that. So in the share market, to reduces the loss in the financial part, right. So this quantum supremacy plays a major roles. Still this implications is there, even though it is helping at the backside, okay. And coming under to the economic and industrial sectors, it is using to reducing the cost and efficiency of the machines, everything. And as I said you previously, for research and innovation things, it is helping us. And in the fundamental physics and all, it is helping us to find all those quantum systems. You might know about this recent movie, right? That's Black movie that Jiva has acted on that movie. Jiva and Priya's acted at that movie. That movie is entirely depends upon this quantum physics only. So this movie is taken as an initiative by one of the just famous director only. So to make this world know about this quantum physics, how it works. So in that movie, the main concept is like they have explained like the same object can be in the multiple places. Say for an example, they will be in a hospital, they will be in a home. So you might think, okay, this will not work in our daily life, but in daily life, so the same thing is happening in a. We'll be in the home, we will be in the office, we will be in the college, and we'll be in the roadsides, we'll be in the car. So the physics will work there. Quantum physics will be working there. So based on the seconds and times, right? So we were in the all places. So that is called superposition. So they have included everything, and they've created on such a good movie actually. So those who knows about this quantum physics can really understand what is happening in that movie. So if you have watched it, okay, that is okay. If you have time, please go ahead and watch that movie if you have not watched it, okay. And also this ethical and societal consideration also, for as I explained you previously, this cryptography for data privacies and everything, only they have introduced this cryptography. And also many new standards has been established at the initial phase of cryptography, right? Many data breaches has happened, and many potential issues and HIPAA issues has been registered on behalf of quantum cryptography. To avoid those cryptography only, they have created one more world that is called post quantum world. In the post quantum world, there is no data breaches, there is no data issues, there is no HIPAA issues, anything will not be there. So there will be data privacy for each and every person in the upcoming world. So what are the information is in your system that cannot be able to hacked, that cannot be able to share with any of the persons without your knowledge. Your passwords cannot be healed. So it's not going to happen suddenly, but in upcoming futures, this data privacy is going to be implemented with the help of this quantum computing. And for skill development also, it's very useful nowadays. Previously, if you want to do some courses or any upgrading, we need to upgrade our skills, we need to go to the centers, okay. We need to go to the centers and take the trainings, or we can play. Previously, YouTube is not that much familiar. Nowadays, YouTube is very familiar, and even though YouTube is familiar, right? So just there is some recognized and professional sites to complete our certifications and trainings, like Udemy is there, Coursera is there. So like that, this kind of Coursera, Udemy, everything. So this kind of learning sites also, they started using this quantum, because every time the person cannot able to answer you at this video, right? This chat GPT is helping you all the time. Whatever the questions you are asking about that video, technically or non-technically, whatever you're having in your mind, if you type right, it will answer for you. So the chat GPT, it helps a lot to expertise in our career. And same way, so what are the things that is keep on developing in this world, right? The same thing, there will be a disadvantage, absolutely there will be some challenges also in the quantum computing. So as I said you, right, the data bridges is the first challenge, okay, because even though they have founded multiple things, right, the data bridges is still happening. And also this to set up this process, right, it takes more places, okay. It needs to be the scalability is very large for this. That one is there. And also, right, if you're doing some program using this quantum computing, deriving some program, right, we cannot able to debug that quantum computing program easily, okay. It takes more time, it is very complex to do debug also, to debug the programming in the coding field, right. It is very little bit tough to handle those kinds of things actually. And also this error rates and quantum noises also, so that can disrupt the processing informations and everything. So for that also, they have found some solutions, okay. So the thing is, like, they keep on discovering. If they are facing any issues, right, they keep on finding the solutions also. That is the good thing this quantum computing has. Previously, we have these issues like it cannot be able to prone all the errors due to the quantum noise, okay. Because of that, we are facing multiple errors. So to handle that one, they found this solution, like this fidelity of the qubit operations. They have developed an advanced algorithm, okay, that is the error correction algorithm. As I said you previously, the scores algorithms, which two boxes were there, I've explained you, right. That concept has been introduced here. So whatever the development you are doing, right, it will create it as an entanglement. Whatever the program you are creating, another entanglement boxes will be created, okay. So the what are the informations you are pushing, right, it will be auto corrected with the help of the error correction algorithm. It will be auto corrected, and it will be providing the outputs. So it will not do any collapse, or you don't want to debug that. So this is the best thing to reduce the noise and error rates. They have found the solution recently. And also this, as I you explained you previously, right, these are the main role of the quantum algorithms, how it is powerful. how this quantum mechanisms, superposition is working. Okay, superposition quantum algorithms is working. How the entanglement cubics is working. These three words will keep on repeating. Okay, superposition, entanglement, interference. Superposition, entanglement, interference. Without these three, right, nothing will not work, and no algorithms will not work. And parallelly we can do parallel application testing, we can do parallel application development, everything can be done simultaneously. Okay, and also few of the algorithms that I have taken you for your reference. Okay, these are the rarely mainly used applications. They have founded multiple n number of algorithms, but these are the very purpose mainly. Hello. Yeah. Okay, these are the notable quantum algorithms, okay, that I have taken you for your reference. This is a Shor algorithms, which I've explained you in the video also, and I've explained you in the oral communication, and this is the written communication also, okay. So this is the as I've explained you, the factorization method, right? So this source algorithm can sort out all kinds of complex issues and everything. This factorizing large numbers, finding the questions for the answers, everything it can be do. This Grover algorithms is also the same, like which I've explained to handling all kind of databases, everything, right? It helps us to find this global algorithm, okay? And the major impact is in the cryptography field for the data security and data privacy, okay? In the data, because in this world, data without data, nothing is working. Data is the main thing, okay? Without data, nothing is there. So the data privacy is very important. So for that only they're introducing cryptography. So cryptography is not that much controllable of the data breaches and everything. To overcome that, they are introducing some algorithms. This Grover algorithms helps us to store the process of the cryptography and the speed up the process. Everything it is helping out. Okay. And also Fourier transform. Fourier transform is nothing but this, it including the Shaw's algorithm. It is transforming all the quantum bits in a crucial time of algorithms. It is not working on all kinds of all kinds of industries. Okay, it can be useful after the Shaw's algorithm. If the Shaw, say for an example, if the factorization number was very large, okay, the Shaw's with the help of the Shaw's algorithm, we can able to find the answer for the factorization. But the multiple factorization was assigned with the n number of times. Okay, 2 power million, 2 power trillion, like that n number of times. At the time, this Fourier transform algorithm will work. So in the periodic function, it will work by 2 power 1. So like that it will work. Okay. So this to solve this n number of periodic function, like periodic 2 power 1, 2 power 2, 2 power 5, 2 power n number of things, right? It's supposed to show algorithms to complete the transformations and quantum bits to perform. The likewise this optimization algorithm also the same, like that only the logistics fields and the networking design, right? Just preparing the diagrams of the civil engineers will be preparing some CAD diagrams, right? To prepare that CAD diagrams, it helps a lot to optimize the diagram. So every time that we need some CAD, ICAD and all, we are having separate tools for that, right? To handle that tool, okay, if the same time multiple person is asking a network design for you, okay, what you will do at the time, just think in a manner. If 1,000 customers approaching you simultaneously, you need to submit to the 1,000 customers within a day or within a 2 days. This quantum computer, with the help of this quantum computing algorithms, you can easily able to do it with a unique solution. Not only unique solutions, multiple solutions can be provided for the single square feet. Say for an example, if the to the civil engineer, I'm asking just I need to construct a home within 1,200 square feet. The same way, in the 1,200 square feet, multiple person is approaching the civil engineer with the different designs. So what he will do, he will go and do some design in the CAD tool, right? So instead of that, right, they can use this algorithm. With the help of this algorithm, for the same 1,200 square feet, 1,000 number, n number of solutions they will provide. It will provide. So they can validate and just submit it to the respective persons. So the same thing, this variational quantum also will work. this for finding this nanomaterials, nanotechnologies, just finding the molecular structures in the physics, right? So it plays in major roles on that, this algorithm. Okay. In the future prospects, everything is going to be just depends on this cryptography. They need to completely depend on this cryptography and cyber security only, because securing the process and securing the data, securing the industries is much important, because the encryption should not happen. To secure the data, they are found, as I said previously, this post quantum world. Post quantum world, this cryptography and cybersecurity plays a major role. Okay, this and all I've explained previously. So this is how it works. So we need to come to the circuit, and we need to find the size of the qubits, and we can add whatever we need. So then we can start running the circuits. Then it will just give us the data estimation of the labor cost and determining everything. So finally, this computing string probabilities can match the results in the quantum supremacy with the help of that. This is how this workflow works. See here, this random quantum circuiting, right? This will measurement can happen. This zeros and ones can send all those informations. It will be sending all those probabilities, and at last, the finally, it will provide the list. This is how it works. So as I said you previously, right? This random circuit proposals. This is one of the. mm, This is one of the algorithm formula. This is called as a brutal force formula. Okay, for quantum computing, getting answers quickly, and for the distribution over to the n number of strings, right? We are using this brute force formula. So here we can apply our whatever the apply things we are doing here, right? I is equal to 1, so I is equal to 100. So it will consider 100 times the same formula and provide the n number of strings and answers sent back quickly. Okay, this is a random circuit proposals and brute force formula. This is. So this bit and qubit, I've explained you the initial slide itself. Here I have just given you the slide communication. So this is the smallest unit. Bit is the smallest unit, but this qubit is the largest. Comparing to classical, it is the largest unit. Okay, and it represents just only zero or either one. But in qubit, it is a 0, 1, and probabilities of zeros, 1. Everything will done same in the parallel calculations. This is how the difference between this bit and qubit. Okay, so the bit how it works and qubit how it works is, if it is yes is 0, it will be n will be 1, and parallelly if we check, right, it will be 0 1 1 0 0 1 1 0 1 1 0 0. So like that it will keep on rotating, and the parallel execution will be happening. And also this measurement, what it is doing, right, it will be like 70% and 30% only. Okay, either it will be 70% or either it will be 30%. Like that only this qubit will work. I'll play this video for your reference.
എന്നിട്ട് നിനക്ക് അയച്ചു തന്നിട്ടില്ല.
എനിക്ക് ആരും അയച്ചു തന്നു.
മായ പറഞ്ഞ ഓക്കെ അയച്ചോ.
சொல்லுங்க மேம்.
உங்களோட சவுண்ட் வரல சொன்னது.
சவுண்ட் வரலையா?
Voice is not audible right now.
So 1 minute, there is an issue, sir. She's clearing that, right?
Okay, thank you, ma'am.
Dear participants, for the next session, unfortunately, Mr. Sarfraz is not available to take the session. So for that, we got approval from AICT Atal to take over the session, the same topic. Dr. Sivagami ma'am from Savita School of Engineering, she will handle this. So the next session will be handled by Dr. Sivagami ma'am, Savita School of Engineering. This is for your kind information. Due to some illness of Mr. Sarfraz, he can't able to take over the session. Sangavi madam.
Sir, signal issue, sir. She is connecting.
Okay, okay. And moreover, participant, this quantum computing is really new technology, and even though we don't have syllabus in curriculum also, but few colleges are autonomous colleges are having the syllabus right now in quantum computing. So everybody is new to this technology. So I hope that everyone will understand the situation, how the session is going on. And moreover, I hope that the last 3 days, 4 days session is very, very good and Today, unfortunately, Mr. Sarfaz is not available to take over the session. He prepared everything, but due to the last minute, he can't able to participate, and he will be admitted in hospital. That is why we change the resource person at the next session.
No problem, sir. All sessions are very interesting so far. It's fine.
Thank you. Thank you so much.
Sanghavi ma'am.
And participant, tomorrow is the last day. It will be start at the 2 o'clock, I think so. So attend all the session tomorrow and complete the feedback session. And we have a quiz test for the end of the session, and we have a validity function on the next day. I mean tomorrow. Okay, so everyone should attend this. I thank everyone. Almost 230 to 225 members are attending daily. So I thank everyone for attending this FDP.
Yes, sir. Thank you, sir.
Thank you. Sanghavi ma'am, are you there?
Yes, sir. Sorry,
Yeah.
some network issue has happened. Yes. Yeah, so I'll just go ahead and show you one thing actually. So you might be using those things, but I'll just go some real time examples, okay? So this is a Microsoft Copilot. So whatever the things you're asking, right? So it's really helpful on this upgrading our technologies, upgrading our knowledges and everything. So just someone can ask me anything, right? I can type here. So this is like chat GPT only. So if I'm asking what is quantum computing, it will be explaining like everything. So what is everything? It will be explaining. So what is the superposition? What is the entanglement? What is the quantum differences? So can you write program for above scenario using Java? It will write. So it will write us. So this is one of the best feature that in this feature also, in this GPT also, quantum computing plays a major role actually. So it will provide us every solutions. So if you are searching answers in Google, right, it will provide us multiple solutions and we cannot able to find the answers properly. But if you are using this kind of Copilot and Gemini, right, it will provide you the accurate solution on how it works and everything. So not only for this coding, right? So everything for learning purposes. If you want any presentation, if you want any notes, if you want any blogs, everything can be get using this Copilot. Everything can be.
Sanghavi, I think it will be background noise is going on. The noise is there.
Okay, sir. Yeah, I can understand. So this is how that we can utilize this Copilot. If you want, I can share that link also. If you are using previously, please ignore.
Sanghavi ma'am. I think we can conclude the session of Sanghavi ma'am, that is quantum supremacy. And the next session will be starting at 7:30. Thank you, participants.
Dear participant, I think there will be a network issue. So almost the time is 7:20. The next session will be started at 7:30. So everyone should join for the next session of handled by Dr. Sivami, ma'am. You can take 10 minutes break, then we can join at 7:30. Sangavi, ma'am.
Yeah, thank you, sir. Thank you so much for the
Yeah,
time, sir.
Sangavi, you have a nice
Network
presentation.
issues
Thank
and
you so much
thank you, sir.
for spending time over at our busy schedule. Thank you so much.
Yeah, thank you, sir. Actually, most of the part I cannot able to conclude it, and sorry for the background noise and network issues.
No
So,
problem, madam.
Okay.
No, we
thank you so
understand.
much. Yes,
It's
thank you so
fine.
much. Yes.
So far, it
Yeah.
was very
Yeah,
interesting.
thank you. Yeah,
And we have tomorrow we have a session at 4 o'clock, I think. 4 or 5 o'clock, ma'am.
yeah, okay, sir. Sure, sir. Thank
We
you
will
so
meet
much.
tomorrow.
Thank you so
Thank you,
much,
ma'am.
sir.
Thank you.
Yes, sir. Thank you,
Thank
sir.
you so
Thank
much.
you so much. Thank you.
So thank you, participants. The next session will be starting at 7:30. Kindly wait.
Good evening, everyone. Again, can you hear my voice?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. This is Shamli from Dhanlakshmi Srinivasan Engineering College. Again, Dr. Shivagami ma'am will join us shortly. Before that, I just want to give some instructions regarding the assessment and the tomorrow session. So tomorrow is the last day of our online FDP, and tomorrow we are going to have 3 sessions. We are going to start sharply at 2 p.m. tomorrow, and 2 to 3:30 we will have one session, and 3:30 to 5 p.m. is going to be the next session, and 5 to 6:30 is going to be the last session, and on 6:30 to 7:30 we are going to have the assessment and also the feedback session. So during the feedback session, the questions will shortly available on your FTP portal at 6:30 p.m. So everyone has to log in your Atal FTP, and you have to complete your assessment given in the dashboard on the left side of your Atal portal. And the questions will be available only between 6:30 to 7:30. Or any internet issues, kindly let me know immediately, because if you are not unable to attend the assessment on the portal means we will send the assessment link up through the WhatsApp group or to your mail ID. Okay, so this is what I have to convey the message regarding the assessment. And the next thing is attendance. So the attendance is partially updated in a portal side by side each day. There are many participants registered for this FTP. So we are doing our attendance updation each and every day. Within Monday, we will conclude the attendance. So once we enter the attendance, we will give the information to you through the WhatsApp group, and you can check your attendance in a portal. If any deviations or if any corrections means, again, just to send or send a message to us. So we will rectify it. Once everything is over means, then we will submit to the attendance. So once the attendance is over, then feedback is completed, you can download your certificate from the Atal portal. So these are all the things these are all the information that we want to share with you. If you have any doubts or any queries means, immediately contact us. Okay, and Shivagami ma'am will sharply join at 7:40 because it's a last minute arrangement. Because our Sarfraz sir is hospitalized due to some issues. So please be on the line for the next 5 minutes. Shivagami ma'am.
Yes, ma'am. My voice is audible.
Yes, ma'am, it's audible. Ma'am, shall we start?
Okay, okay.
Okay.
Okay, ma'am.
Deepika ma'am.
Yes,
Deepika
ma'am.
ma'am.
Yes,
Okay,
ma'am.
ma'am, you can give a welcome address for Dr. Shivagami ma'am.
Okay, ma'am. Okay, ma'am. Good evening to all. Now we are going to enter into the next session, which is presented by Dr. S. Sivagami, who is working as an associate professor, Safita School of Engineering, Chennai. It's my great pleasure to welcome Dr. S. Sivagami, a renowned expert in the field of computer science, to our faculty development program today. She was completed her PhD in Tyagarajar College of Engineering, Madurai. She has more than 15 years of experience in teaching field. She received Best Teaching and Research Excellence Award from Sendalir Human Development Trust in the year of 2023 and also received Academic Excellence Award from Educators Empowering India in the year of 2024. She was guided more than 70 UG and 7 PG students in various domains. She also reviewer for IEEE sponsored international conference and many Scopus indexed journal. She published more than 10 international journal and various book chapters. So we are grateful for yes Sivagami ma'am willingness to share her time and expertise with us. We look forward to stimulating and informative session and we are confident that her presentation will be valuable addition to our FTP. Once again, I am welcoming Dr. S. Sivagami ma'am for this FTP and also welcoming all the participants to take active part in this session. Welcoming you all. Thank you.
Thank you, ma'am. Okay, good evening to all. Thank you for this wonderful opportunity given by our management and Lakshmi Singh Engineering College. I once again thank you all the organizers, Francis Shamili ma'am, who is the HOD of BSc department, and Gokula Krishnan sir, other teaching staff members, and members of Lakshmi Singh Engineering College. Okay, thank you once again. Okay, let's start, ma'am.
Shivagami ma'am, your voice is breaking.
Now it's clear.
No, ma'am, it's breaking.
Shamli ma'am, now it's okay. Now it's okay, ma'am. I'm in correct position only.
Okay, ma'am. Okay, ma'am.
If my voice is audible, please.
No, ma'am, still it's breaking. Not clear.
Now it's my voice is clear?
Yes,
Yes,
ma'am,
ma'am. Clear,
audible.
ma'am. Clear.
Okay, thank you so much, ma'am. Sorry for the inconvenience. Okay, shall I start the session, ma'am?
Yes, ma'am. Yes, ma'am.
Okay, good evening to all. Okay, once again, I am sorry. Suddenly they gave this opportunity. I have somewhat clear idea about this quantum computing. Just I want to share my ideas into this. Okay, kindly cooperate myself. Is there any doubt? Means you kindly enter into the chat box. I clear and I send to you. Send to you. Okay, thank you. Shall I start my session?
Yes, ma'am.
Yes, madam.
Okay, thank you. My slides is visible.
Yes,
Visible,
ma'am.
ma'am.
Okay, thank you. Okay, once again, very good afternoon. Okay, this is the introduction of quantum computing. We know that several types of computing. Can anyone tell that what are the several types of computing? Why we are going for quantum computing? Anyone?
Because of fast and accuracy, ma'am.
Yes, sir. Very good,
We
sir.
go
Thank you.
for quantum computing.
Thank you for your response, sir. Okay, what are the different types of computing, sir?
Classical computing, supercomputing.
Yes, sir. Yes, sir. Okay, thank you for your response, sir. You know that why we are going for computing means it depends upon that we have to compute our data very fastly. Okay, so only first we started with the distributed computing. After that, we are enter into the parallel computing because parallel computing it computes in a parallel manner. Okay, after that classical computing. Okay, finally the another one thing is called as a quantum computing. Okay, that's it. That's we are all clear about that. Okay, it is the definition for quantum computing. Okay, quantum computing is an area of computer science that uses the principles of quantum theory. Okay, I already know about that. What is meant by bits? Okay, either it is to be zeros or ones. Okay, it should be that. That's only one state. Okay, either it is to be zero or it is to be one. That is called as the bit. Bit is carry some informations. Okay, and then here it is to be related to be here. Okay, quantum theory explains the behaviors of energy and material on the atomic and subatomic levels. So what is that atomic levels means? It can't be. It should be similar. It means it should be minute process. But it gives some more details. Okay, likewise here it explains the behaviors of energy and material on the atomic and subatomic levels. Quantum computing uses subatomic particles such as electrons or photons. We already studied in this physics also. Okay, so quantum bits or qubits allow these particles to exist in more than one state. Okay, that is 1 and 0 at the same time. 1 and 0 at the same time. Okay, this is the simple definition for quantum computing. Okay, the next one, okay, it is a qubit. Okay, like this in somewhat a bit is called as a zeros and ones. Qubit is either zeros or ones at the same time. A qubit is a two-level quantum system where the two basis qubit states are usually written as 1 by root 2 modulus of 0 and 1 by root 2 modulus of 1. Either it is to be in two states at the same times. A qubit can be in state of 1 by root 2 slash 0 and 1 by root 2 modulus of 1. Okay, or unlike classical bits, it is a linear combinations of both the states. The phenomenon is called as the superpositions. Okay, I hope these and all you know about the basic concepts of quantum computings and all. Okay, the next one. Okay, this is the graphical representations of qubit. Okay, first the general classical bits. Okay, whether we are sending either 0 or 1, it is to be followed 1 out of 2 power n possible permutations. Okay, but in case of quantum bit, we are sending that only both zeros and 1. It will get 2 power n possible permutations at a time. So this is the difference between the classical bits and the quantum bit. Okay. Everything now we are in the current era, but we know what is the evaluations of quantum computer. First, it starts by 1982. The great scientist Richard Feynman proposed the idea of creating machine based on the laws of some quantum mechanics. Based upon the mechanics and physics only, we have to come into the computer sections. Okay, so collections of both the mechanics and the physics, somewhat in the physics, and both these all the phenomena are going to create somewhat computation process. Okay, that is called as the computing. Okay, fine. So after that after 3 years, 1985, David Dusko developed the quantum Turing machines, showing that quantum circuits are universals. You know that circuits and all. Okay, so they have developed some of the quantum Turing machines. After that, 1994, Peter Schover came with a quantum algorithm. A quantum algorithm to factor very large numbers in polynomial time. Okay, after that, 1997, Love Grover develops a quantum algorithm. Finally, it's come to that quantum computing. Okay, these are the evaluations of quantum computer. It starts from 1982. Now we are in 2024. It should be in the high demanded computing nowadays. Okay, this is the quantum superposition. Okay, the quantum systems it should be capable of being in several different states at the same time. Okay, I already explained that either it is to be 0 or it is to be 1. It is in the classical computing, but in case of quantum computing, it should be in several different states at the same time. Either it is to be zeros and ones, and it is to be another 1 and 0. Okay, but different states at the same time. For example, Young's double slit experiment, it is to be already studied in the physics. Okay, we are forming some light sources and it is formed into the metal sheet. The metal sheet, after the light sources from the metal sheet, it distracts some of the light sources, and finally it is to be projected in the screen. This is called as the double slit experiments. So finally we get the correct images. Okay, this is that quantum superposition. Next one, quantum entanglement. Okay, entanglement in the sense it is an extremely strong correlations that exist between the quantum particles. Okay, some terms that is to be from that physics, but we have to coordinate the physics and computing. We just compare with the physics and computing and the mechanics somewhat areas. We have to coordinate all those things which comes into the end of the quantum computing. Okay. Two or more quantum particles, there is an example here. Two or more quantum particles can be inextricably linked in perfect unison even when placed at the opposite ends of the universe also. Okay, this entanglement is called as the spooking actions at a distance. Okay, either it is a distance, but you have to done something about that. Okay, next still now we talk about that what is that physics, what is that quantum in terms of physics, what is that quantum in terms of mechanics. After that now this is the slide explain how quantum computer will work. Okay, this only we need. Okay, here they are give some examples for this. Okay, for clear understanding. Okay, we are inviting 5 colleagues to a wedding and you need to plan the seating arrangements. Okay, the total number of ways to do so is 5 factorial equal to 120. So computing tends to evaluate 120 possibilities and compare them and then decide on the final optimizations. However, a quantum computer undertakes the following steps. steps for optimizing the seat allocation. Okay. The first one, consider the qubits and create quantum. What is that? Where all the superpositions for all possible quantum states. The next one, the encoder, it applies phase to each quantum state. Okay, and configure the qubits. For example, it is to be zeros, it is to be one, after that it is to be zero, after that it is to be one, after that it is to be one, like that it will change. Okay, for that possible sitting waves that fall in phase, the amplitudes add up, while for the out of phase waves, the amplitudes cancel out. Okay, this is a simple phenomenon. Okay, whether the possible sitting, okay, waves that falls in pass, we have to pass means the amplitude will add. Okay, while the out of phase waves means the amplitude just cancel out and exit from that. Okay, here is the quantum computer then uses interferences to reinforce and amplify some answers. Okay, it has interferences means it just intermediate to all those things, and finally it will find out the somewhat answer. As a result, a single solution for optimized seat allocation is finally reached. Okay. Already explained that in previous slide. Okay, we are going to invite 5 colleagues in our wedding. The total number of ways is to 5 factor equal to 120 ways. Okay, the next one, we are consider some of the qubits and create quantum superpositions. Okay, what are all the possible quantum states? How they have to sit according to their order. Okay, how they have to sit in the superpositioning manner. Okay, like this, using that interferences to reinforce or amplify some answers and or cancel or diminish the others. We just amplify some of the answers. Yeah, as a result of this, a single solutions to be performed for for seat allocations. Okay. The next one, why we are going for quantum computing. Okay. Quantum computing take up a fraction of the space of classical computers. We know that already classical by level of power that can find solutions to problems out of the reach of today's computers. Okay, so we have to decrease the size of the transistors. We are gradually approaching to the atom stage, beyond which we can't move down the quantum mechanics, which in turn gives rise to quantum computing. Okay. And then there is a definitions like this: a quantum computer can create superposition with multiple probabilities. Applications, sorry for that. With this type of applications, the quantum computer will be much more efficient than the classical computer. Okay, with the high speed of transmission, high speed of performance only, we are going for quantum computing. Okay. This is the types of quantum computings. There are quantum annealing, quantum simulations, and universal quantum. Okay, which we'll see in that further slides. The first one, quantum annealing. Okay, it is best for solving optimization narrowly applied form of quantum computing. Okay, they are giving some examples also. Just to read it out. Recently, they are taken at Volkswagen. We know that conducted a quantum experiment to optimize traffic flows in the overcrowded city of Beijing, China. Okay. The experiment was run in partnership with Google and DV systems, which successfully reduced traffic by choosing that ideal path for each vehicle. Okay. What is that? Which paths have to go? But classical computers would take thousands of years to compute the optimum solutions to such a problem. But quantum computers have to be clear the problem within a few hours. Okay, because the speed of the quantum computing is very high with compared with the classical computing. Okay, using such algorithm, they are using they have to partnership with the Google and the DWave systems. You know that Google Track and all. Okay, they just partnership with the Google and DWave systems. Where the quantum with the help of the quantum computing, it reduces the traffic by choosing the ideal path compared to classical computing, the quantum computing speed and the performance of that quantum computing is very much high. The next one, quantum simulations. Okay, every thing we have to simulate of this is quantum simulations explores specific problems in quantum physics that are beyond the capacity of the classical systems. So it simulates and induces the complex quantum phenomena. It could be one of the most important applications of the quantum computing. Then it simulates that with the help of that program and also we have to simulate that computer process and we can get some more speed in the our system. The quantum simulation. The quantum simulators could be used to simulate protein folding. They are given the biostatistic problems, how to discuss using success and all. Next one, universal quantum means it should be the most powerful and most generally applicable. Okay, but it's also the hardest to build. Okay, so we have to assemble all those systems. Okay, and we have to process that this. So here they are using of 1 lakh qubits. Okay. The basic idea is that machines and any massively complex computation and get a quick solution. Universal quantum it helps the machine learning algorithms. We have used the we have to use the various sectors. Drawbacks means algorithms for the quantum computers somewhat somewhat it is not be normal, like can they have the low temperature needed, it is not open for like computing and then internet security. The next one, it usually take what are the take using that
Ma'am, Shivagami ma'am, your presentation is not visible for us, ma'am. Slides.
No, audio is audible, but PPT don't show. Audio is okay.
Shivagami ma'am.
Is there any issue?
Yes, please wait. Ma'am is reconnecting. Your screen is visible now, ma'am.
Dear participants, due to some technical issues, Shivagami ma'am will connect within few seconds. Kindly wait. Sir, she is connecting, sir. Kindly wait. And she's having some network issues, I think so.
Now okay, ma'am.
Now the video is shared.
Now okay, ma'am.
Yes,
Visible.
yes, ma'am. Yes, ma'am. It's visible.
Ma'am, it's a video or PPT? It's not
Video
moving,
sharing. Video.
but not playing, ma'am.
Sir, network break, sir. Now sir.
The voice is not clear, ma'am.
Is it sir?
No, ma'am. Voice is breaking.
Shivagami ma'am, screen is not visible. Just it is showing presenting only.
I can't to wait, ma'am.
Your voice is also not audible, right? It is.
Now the screen is
Now
visible.
visible, ma'am. You can go ahead.
Yes,
Quantum
it is visible.
computing, sir. Quantum computing.
Yes, ma'am. Go ahead. It's visible.
Okay, sir. Thank you.
Okay.
Sorry for that inconvenience, sir. I'm
Okay.
really
Okay,
very
ma'am.
much sorry
Okay,
here.
ma'am.
The next one, we are going to simulate our quantum computing with the help of the R. Okay, how many of you know about the R programming? Okay, directly comes to that R programming. Okay, here they gave some of the difference between qubit and the classic bit. Qubit stands for, you know, that quantum computing, and whereas in classical bit stands for the classical compute. Okay, here they are given some differences here. Okay, first of all, they are given as state representations. Okay, in the first slide itself, I explained that a classical bit can exist in one of the following two states. Okay, whether it is to be 0 or it is to be 1. Okay, it can be thought to as a simple, whether it is to be on switch or it is to be off switch. Okay, from these definitions, we come to know that there is one state at a time. Okay, in terms of qubit representations, a qubit can exist in a state of 0, 1, or both 0 and 1 simultaneously. Okay, which is based on the property of quantum superposition. Okay, this is the state representation. Okay, the next one, what is we are going to say about it? What is the superposition between the qubit and the classical bit? Okay, yeah, superposition. In case of classical computing, it's always either one of the two states. But in case of, already I explained that both the zeros and ones, or it is to be on and off at the same times. Okay, why they are following here means it allows to perform multiple calculations simultaneously. Okay, likewise the parallel computing, but compared with the parallel computing, the quantum computing it performs well. Okay, and it have performed multiple calculations simultaneously. Okay, the third category is, okay, quantum entanglement. Okay, this entanglement in case of classical computing, it operates independently of each other. Okay, it does not affect the other state. It does not affect the other state of another bit, so they have to operate independently. But in terms of quantum computing, qubits can be entangled. It means that the state of one qubit is directly connected to the state of another qubit. Okay, regardless of the distance of separations. Okay, which is the difference between the classical computing and the quantum computing. And in terms of measurement, when you check the state of a classical bit, whether it is to be 0 or it is to be 1, and the state is not changed. Okay, it should be fixed when we tend to measure them. But in case of quantum computing, the measuring a qubit forces it to collapses one of the definite states, whether it is to be 0 or it is to be 1. It exists in a superpositions of both the states. Okay. For example, we have taken that R programming for quantum computing simulations. It is one of the best tool for statistical simulations, and it compared with other programming, it is so user friendly. Also, it has so much of packages compared with other R programming. It is user friendly too. Okay. Now R is the best tool to start with that quantum computing availability of packages. Okay, it have several amount of high packages that is used for data analysis, visualization, and also for quantum simulations. Okay, the help of the R programming, we are simulate our quantum computing and perform many operations at the same time. Okay, and then syntax for R is also very easy to learn and very easy to understand also. Performing the calculations in R programming and simulate our computing part and all, that is very easy to the beginners also. Okay. Why we are choosing the R programming means we are integrations with other tools also, okay, such as Pythons. Python in the sense that we know that some machine learning algorithm, it is the best tool for everything. The in R programming is also integrated with Python programming and gives both the users to combine the strength of multiple languages in their quantum simulations. Okay. And it have R programming have visualization capabilities also. Okay, in case of C and C++, we have to include graphics.h. Okay, likewise here we have to install that ggplot2, that is graphics plot2. Okay, it allows users to create interesting plots. Okay, interesting plots like bar charts, pie charts, scatter plots, heat maps, and all. Okay, to analyze and understand the data very easily. Okay. Here some of the key packages for quantum computing in R. Okay, how many? I don't know how many of you know about the R programming, but it is the best tool for visualizing all those things. Okay, and it is a compatibility tool, and it is also integrated with other tool and execute the process very much easy. Okay. Here some of I am going to explain some of the key packages for quantum computing. The first one, the first packages, okay, the same only we have to install for drawing the graphics operations. We have to install ggplot2. Okay, likewise in R programming we have to simulate our quantum computing, means we have to use that Q simulate R keyword. Okay, what is that? Q simulate, SAMULATR. Okay, we have to install that packages. Okay, what is that Q simulate packages means? This simulator is used for educational purposes, and it is also defined. It is a basic. It is the basic simulators for the using for the educational purposes. And it performs some quantum gates and all, and it measures qubit states. You already explained that qubit states, whether it is to be 0 or it is to be 1, or both the combinations of zeros and ones. Yeah, and it is great for learning the basics of quantum mechanics and the quantum computings also. We have to install that QSimulate R. Then the next one, the next packages is Quantum OPS. Okay, OOPS. Okay, it provides tools to perform quantum operations. From the name itself, Quantum OPS. Okay, OPS stands for operations. It simulates some of the quantum circuits. Okay, quantum circuits in the sense that we have to use AND gate, OR gate, and apply some quantum gates and perform that perfect outcomes. It is also suitable for simulating small scale quantum circuits, and there are several algorithms, you know, the Grover's algorithms and the source algorithms also. Okay, this is that this is the only thing we are using that quantum operation package in R. Okay, next one, QSkit via reticulate. Okay, these packages is formed by that IBM QSkit framework along with the Python integrations also. It uses to run quantum algorithms on IBM quantum process. Okay, best advanced users to explore real quantum hardware simulations, whether it is to be implement a simple quantum algorithms or to be complex quantum algorithms. Okay, these are the three packages to simulate our quantum computing in the R programming. Okay, the next one, a simple quantum circuit in R. Okay, how to install that? How to install the simple quantum circuit in R? Okay, whether it is to be whatever it may be, we have to first install our packages. I already explained that. Install our packages of Q simulate R. Okay, and then we have to call all the library files that is to be included in the Q simulate R. Okay, the next one, we are going to calculate the quantum bits also. So quantum bits, whether it is to be 2 bits, that is n number of bits to be equal to 2, we have to install that state and then q state. Okay, q state stands for quantum state and n bits is equal to 2. Okay, and then print of initial state and print of state. So it is to be display that what is the states of the bits. See here, first it will print that initial state. The initial state should be 0. Okay, after that it is to be changed into the another one thing. Okay, this is a simple program. First we have to install that QStimulate R packages. Okay, and the next one we have to calculate how many numbers of bits that is to be passed in the quantum manner. Okay, so we have to install that state. Q state stands for quantum state. We are passing that n bits is equal to 2 and then print of initial state, print of state. Okay, so we are after declaring this, we have to print the initial state. What is that initial state that belongs to? Okay, the next one, apply quantum gates also. Gates in the sense we are going to apply what is that superposition of that quantum computing. So here we are initialize that H, often denoted as H, is the fundamental quantum gate is used in quantum computing, that is used to create some superposition states. So we are have to using that that is that Hadamard gate. So we are using that H underscore gates to H of 1, and we have to calculate the result, what is the states of the H1, and we have to multiply into the state. Okay, already we get that states also. So it start state after applying the Hadamard gate. So it will print the results like this. Okay, what is that state after applying Hadamard gate? What is the state before itself? That is to be 0 and 0. After applying that Hadamard gate, it is to be in 0 and 1 position. It is called as the superpositions of that quantum computing. Okay, the fourth step, we have to measure the qubit. Okay, measure the qubits means where we are how many repetitions also there, what is the results of the qubit position. See here the same thing. First one, we are passing one of the states. After the repetition, it is to be 1. The probability values, it is to be 0.1. It is the probability distribution, so it will be less than 1, 0.5, 0.5 like that. After that, using the Hadamard gate, it is to be changes into 0, and finally we are getting that measurement list. Okay, this is that quantum computing. We are using that R language. Okay, I just want to explain that in R prompt how to declare that quantum computing center. Okay, we know that how many of you, I don't know how many of you know that R bit. First we have to see that I installed my system R prompt, so I just to open. Okay, and then click that install dot packages. Oh, just what are the packages I have to install in R? Okay, install the packages of QStimulator and the library of QStimulator. We just run into that. Okay, after that they are installing what are the packages we are in need. Just it install that packages. It's running on. Take some time to install the packages. I think it takes too much of time. I think it is going on. Or else you have to go to that packages, load package. Okay, load package. Okay, I think it take me so much of time for loading the packages. Here it will give some error messages. So just another one time we have to install that. Better we come out of that our programming. I just explained. Okay, these are that simulating a quantum circuit in R programming. Okay. Next, we have to see that. This video is visible. The video is visible now.
Yes, ma'am.
Yes, madam.
Just a practical implementation of the quantum computing.
Not able to hear, ma'am.
Madam, I think you are muted.
Yes, madam, we can't hear.
Not showing presentation and also not.
Okay, wait for 2 minutes, sir. Sir, now it's hearing one video.
No, ma'am.
Okay, wait a minute, ma'am. Ma'am, now it's clear. Now the video is visible. Ma'am, could anyone hear this
Video is
video voice?
visible, madam, but
No,
audio.
ma'am. No, ma'am.
Yes, ma'am.
Now showing.
It's a simple thing for quantum computing video.
Yes, we can see now, madam. It's moving.
Okay, thank you, sir. Here network connection seems to be very less. Is my voice also audible now? Is my voice is audible?
Right now, audible, ma'am.
We can hear you, madam.
Okay, sir. Sorry for that inconvenience of the poor network here. Okay, here somewhat raining. Okay, I hope that I just I inform that what is that qubits and all. Okay, thank you one and all. Thank you for giving this great opportunity. Herewith I conclude that quantum computing sessions. Thank you all.
Thank you, ma'am.
Thank you, madam. Shall I ask one doubt, ma'am?
Yes, sir.
Madam, when we are working with a large-scale quantum computing simulation, how to
Okay,
address
sir.
the performance over that in our programming? Our programming is a predetermined one.
Yes, sir.
How to face the performance overhead in
Sir,
our
I
programming? Because we can integrate our program with the quantum computing, isn't it? Hello? My voice is audible, ma'am.
channel